Hello students, welcome back to the Tantray physics classes. Today we are discussing one more problem, challenging problem, good for IIT aspirants and also for those who want to go for this physics Olympiad. The problem is on electrodynamics, changing magnetic field, and the problem is like this. Is a region of magnetic field. Magnetic field is inverse in this cylindrical region. It's a cylindrical region, but the magnetic field is just inverse. And that magnetic field changes with time and is given by this expression B is equal to 2t cube minus 4t square plus 0.8. And this magnetic field is over a region of radius 2.5 centimeters in this region. But obviously this magnetic field is changing. And as you know, the changing magnetic field creates electric field. It is different from the electric field that we produce by stationary charges. A changing magnetic field, the magnetic field which changes in magnitude and direction, that also produces electric field. But that electric field is a little different from the electric field which is produced by stationary charges. This electric field is non-conservative electric field. The electric field produced by the changing magnetic field is one which is non-conservative. And that field which is created by the stationary charge is conservative field. And this field, this electric field, is produced in circles around changing magnetic field. If magnetic field is this and is changing in magnitude, this is the magnetic field direction, and let me suppose it changes in magnitude, it produces electric field in circles around it. Obviously, if you go away from the changing magnetic field, the electric field should decrease as you go away from the source. But it is all created in circles around this changing magnetic field. The same way as the magnetic field is produced in circles around a current carrying conductor. So a changing magnetic field produces electric field, that also in circles. The question is, this is a magnetic field which is changing in time like this, it will produce electric field in circles around. And if we have electron here at point P, how much is the force on this electron due to that electric field which is produced in circles around this changing magnetic field? That's all. So first we have to find how much magnetic field is produced here, how much electric field is produced in this circle, and what is the direction of that electric field. It will be tangential to this circle. The electric field will be tangential. But will it be clockwise or anti-clockwise or clockwise? Depends. If electric field is positive, that we are getting from the derivation, if electric field is positive, then the electric field direction is anti-clockwise. If the electric field becomes negative, then the electric field is clockwise. If it is negative, that we have to see. So, the basic concept is the changing magnetic field produces electric field in circles. In this circle, the electric field will be produced. And on point P, there is an electron. We have to find the force on this electron. First, let me find the electric field. Right? So, how to find the electric field around this changing magnetic field? It's a changing magnetic field. How to find the electric field in this, around this changing magnetic field? The base equation is the electric field which is produced around this changing magnetic field is according to Faraday's law, one of the Maxwell's equations, that's integration E dot dl is equal to minus d phi b by dt. This is the rule. The change in magnetic flux, this is the change in magnetic flux, the source for electric field, and electric field is produced in circles. Right? The electric field produced in circles around this changing magnetic field, the integration of that electric field over the whole path, the integration of electric field over this whole path is equal to how much flux is changing per unit time here in this region. Is region mein kitna, what's the rate of change in magnetic flux in this region will produce electric field in circles, and if you integrate electric field over this closed path, that will be equal to minus d by dt of pi here. So this is the base equation. Inside flux, influx is taken as negative. That is the rule. When we get positive electric field, that will be anti-clockwise, and the direction of the electric field will be anti-clockwise if we get the electric field as positive. in the derivation. Okay, now it's integration of E. What is this is the direction of the, let me suppose this is the direction of electric field. E dot dl, if you integrate electric field over this path, so it will be E dl cos of 0. Why? Because the angle between electric field and path length, this path length is 0. So that will be minus d by dt. What is flux? What is flux here in this region? That is pi r square b with a negative sign, because the flux inwards with a negative sign. So this will become positive. So E will be out, integration will be dl is equal to pi r square out, and differentiation will be of magnetic field, because it is the magnetic field which changes, that cause the change in flux, not the area of this cylindrical region. So it will be E, it will be L pi r square d by dt. What is the magnetic field given? That is 2t cube minus 4t square plus 0.8. So that will be E into, what is the total length of this circle? That is 2 pi r. 2 pi small r. 2 pi small r is equal to pi r square. इसका differentiation 6t minus 8t. इसका 0. Back, close the brackets. Pi gets cancelled. And what is the electric field? That is r square by 2r 6t minus 8, 6t square 8t. We found the electric field at a distance r. यहाँ पर क्या electric field है at a distance r? That is given by this expression, right? So is the electric field clockwise or anti-clockwise? Let us find. Yes, the question was, what is the force on the electron here? We found the electric field here, but we had to find force at some time. At time t is equal to 2 seconds. Though after 2 seconds, what is the force on the electron there? Because the electric field becomes a function of time, so we have to give the time as particular value. So why not find the electric field at time t is equal to 2 seconds? If I find electric field there and find the electric field direction also, then I will put electron there, then I can find the force on the electron. Because you know, force on the electron or charge is equal to Q into E. Charge into electric field. That is the force. But let's first find the electric field at that point here. That is given by r square by 2r 6t square minus 8t. Right? Okay. The electric field that we obtained is E equal to, okay, that is r square by 2r 6t square minus 8t. That is our electric field produced at point P at a distance r from the center of the field. Okay. Now, at time t is equal to 2 seconds, what is the electric field? That is r square by 2r into 2, 4, this is 24 minus 16. By substituting t is equal to 2, that is 16, that is 24. Okay, the E is equal to, that is r square by 2r into 24, 16, 6, 7, 8, 9, 10. It is 8 only. Okay, it is 2 4s are 8. It is E equal to 4r square by small r. Right? That is our electric field. Okay, now if we get this electric field, what is this for electric field clockwise or anti-clockwise? The electric field is anti-clockwise. Why? Because the electric field becomes positive. Positive electric field is anti-clockwise. Now, what is the force on the electron? The force on the electron will be, okay, the force on the electron will be, that is F is equal to QE, that is Q is minus E, and the force will be clockwise because it is opposite to the electric field. Electric field is clockwise, but force will be anti-clockwise. So the force on the electron will be this direction, F. And how much is that force? That is minus E. What is electric field? 4r square by small r. Right? And if you substitute these values, you get the force. F is equal to 4 r square by small r with a negative sign. This is the force. If you substitute all the values, it will be, if you substitute all the values, it will be 8.0 into 10 raised power minus 21 Newton. That is the answer. So the concept was like this. The concept was the changing magnetic field produces electric field, and that electric field acts on the electron. So we were given the magnetic field. We change with time. This changing magnetic field creates electric field in circles, right? And we had to find the electric field here at this point, and that we used the formula of that was what you call as Maxwell's equation. Integration of E dot dl is equal to minus d phi by dt. And we got the electric field here. Then we place the electron here, and there's a force on this electron due to this electric field. Electric field has this direction because we got the positive value of electric field, and the force opposite to the electric field because it is a negative electron placed in the electric field. This was one more challenging problem for you. You continue with watching the challenging problems so that you can prepare for IIT, and you can also prepare for the Olympiad if you want. Okay, thank you.